Black holes are the most extreme objects in the known universe. They are places where gravity becomes so powerful that not even light can break free once it crosses the event horizon. That means a black hole is not just dangerous. It is one of the few places where our normal intuition about reality stops working. So what would really happen if a human being moved toward one? The answer begins long before your body is torn apart. It begins with what you see, what you feel, and how time itself starts to change around you. To understand that journey, we first need to understand what a black hole actually is. Many black holes are born when an enormous star reaches the end of its life and can no longer support its own weight. The outer layers explode outward, but the core collapses inward under a crushing force so strong that matter is squeezed into an unimaginably tiny region. The mass is still there. It has simply been packed into a smaller and smaller volume. As that density rises, gravity becomes extreme enough to bend space and time themselves. At a certain boundary, the escape speed becomes greater than the speed of light. That boundary is the event horizon, the point beyond which the outside universe can no longer receive anything back. If you started falling toward a black hole, the first thing to fail would not be your body. It would be your view of the universe. The black hole would bend the path of light around it, twisting the stars into bright arcs and rings. Objects behind the black hole could appear above, below, or even around it in warped and impossible positions. This effect is called gravitational lensing, and it is one of the clearest demonstrations that gravity does not just pull on matter. It also reshapes the path taken by light itself. Before the black hole touched you physically, it would already be rewriting your sense of direction and distance. As you moved closer to the event horizon, there would be no solid wall, no fiery gate, and no obvious line painted in space. From your own point of view, you might continue drifting inward without noticing any sudden boundary at all. That is part of what makes black holes so unsettling. Their most important border can be physically invisible. But for someone watching from far away, your fall would look completely different. You would appear to slow down, dim, and shift toward redder wavelengths as your light struggled to escape the growing gravity around you. To that distant observer, it could seem as if you never fully crossed the horizon at all. Then the strangest effect would begin. Time itself would separate your experience from the rest of the universe. Close to a black hole, time moves more slowly than it does far away. This is not science fiction. It is a real prediction of general relativity. For you, the journey inward might feel brief. For a distant observer, far more time could pass. In extreme cases, minutes for you could correspond to years for someone safely outside the black hole's pull. Gravity would not merely threaten your body. It would break the shared rhythm of time between you and everyone else. That is one reason black holes are more than cosmic traps. They are laboratories for the deepest rules of reality. Eventually, gravity would stop being a distant force and begin acting differently on different parts of your body. If your feet were closer to the black hole than your head, they would feel a stronger pull. That difference in force is called a tidal effect, and near a black hole it can become catastrophic. Your body would begin to stretch into a longer and thinner shape as gravity pulled unevenly across you. Scientists informally call this spaghettification. The name sounds almost playful, but the process would be one of the most violent endings nature can produce. Not every black hole would destroy you in exactly the same way. A smaller stellar black hole has a much steeper gravitational gradient near the horizon, which means tidal forces can become lethal before you even cross it. A supermassive black hole behaves differently. Because its event horizon is much larger, the change in gravity across your body at that boundary can be less extreme. In theory, you might cross the horizon of a supermassive black hole without feeling an immediate physical disaster at that exact moment. The fatal forces would still come later, deeper inside, where escape becomes completely impossible. And then we reach the most mysterious part of all, the place our current theories still cannot fully describe. At the center of a classical black hole lies the singularity, a region where density appears to become infinite and our equations begin to fail. This is the point where general relativity and quantum physics stop agreeing in any complete way. We know black holes are real. We know their gravity shapes galaxies and bends light. But what ultimately happens to information, matter, and the structure of space inside them remains one of the biggest open questions in modern science. In other words, the deeper you go into a black hole, the closer you come to the edge of human knowledge itself. Falling into a black hole is not just a thought experiment about death. It is a journey into the place where light, time, gravity, and matter stop behaving the way we expect. And that is why black holes are not only terrifying. They are also some of the most valuable objects in the universe for understanding the laws that govern everything. The darkest places in the cosmos may be hiding the clearest clues about how reality is built. And until we solve them, black holes will remain both our greatest warning and one of our greatest scientific invitations. They do not simply swallow matter. They challenge the limits of what the universe will allow us to know.